at that point, I've been a Blender developer since 2003, but before that I studied Finnish language at the Khronos University in the Netherlands and at the Turku University in Finland. I kind of started this stuff as a hobby. Then for me was to actually learn programming. I'm still with the program. So I'm still with the Blender Foundation, working as a developer, mainly voluntarily. In 2011, this year, beginning March, I started the studio with 4 other guys to do something more with Blender. I have been working first on the game engine in Blender, fixing up the project files. They were a complete mess in 2002, 2003. After that, I started to be interested with the Khronos build system. I have been working on it since 2004 and still maintain texture material. I also, of course, Python on scripting. And in 2009, participated in our design event for Blender 2.5 series. Overall very active in the Blender community, trying to give as much information to people as possible. And I like to do weird things, so I have some experimental stuff, DB Blender, Blender with a database as backend, first implementation. Has anybody heard about FIRST? It's a very cool network protocol for 3D data, enabling real-time collaboration. And Python is cool, but I like Lua better. I tried to do a Lua scripting API in Blender. It worked essentially, but it's a lot of work, so I dropped it. Blender itself, open source modeling and animation suite with a lot of capabilities. Rigging, animation, sculpting, texturing, video editing. Actually with this year's Google Summer of Code projects, we have 70 projects running with a few very high profile projects, so one of them being motion tracking. I don't know if you have been at our booth in the trade show, but if you haven't been there yet, you should go and check it out. It's closed. It's closed? Oh no. And one project is the COLLADA animation improvements, for which I'm mentoring. I just downloaded from my home machine a build with the student's work, and I don't know if it actually works. There were some troubles with crashing. We'll see if it works later on. Right now we are working on Blender 2.59. It's not yet officially released, and I just noticed from IRC that some crasher had been found, so everybody's in panic. We will update the builds in the link you can find on this slide. So COLLADA in Blender. Before 2.5 we had COLLADA integration with through our Python API. But with 2.5, since the 2009 Google Summer of Code project, we have essentially integrated COLLADA support using the open COLLADA library. And the maintainer for this module in Blender kind of got busy with other stuff. And last year, at the end of the year, when I got contracted by Blender Foundation to work on bug fixing, I saw a huge amount of COLLADA bugs. Nobody wanted to work on it, so I adopted this. And I still work on this with 2011, this year's, because of Google Summer of Code animation support project to have export and import. And currently the student is working on armature animation baking, so that it's easier to export to, for instance, game engines. So some links we have for our development. On our wiki we have source architecture COLLADA. Open somewhere. So this is the current kind of roadmap we have. What we still need to do, as you can see, is enough work to do. So if you have coding capabilities and are bored, please help. And these are the features we already support: light, material, textures, mesh types. Most of the mesh types, not all. Like lines are not working. Instancing works, animation works. For the current version truck, it works for some cases, but not all. And that's what this Google Summer Code project is about, in improving the support for animation. And the other page is more for the users. We're still work in progress, also mainly because I'm still working on developing these and trying to organize developers who are interested in helping out in improving our support. And a short overview. I try to maintain it, but it's not always very easy to make this kind of table. But this is essentially the table of tags for the 1.4.1 COLLADA reference specification about what we support and what we don't support. I have not filled out everything because I have been lazy again. But whenever I have time to really work on this, then I'll be adding more information on what we do support and what we don't support. And also write down the peculiarities, how to export, for instance, textured objects. I have since this year started Blender COLLADA channel. I noticed that a lot of people are interested in COLLADA supporting Blender, but the amount of talk was a little bit noisy for the normal development, so Blender COLLADA channel on Freenode is where you can find us.
What's your handle on?
I wrote it at the beginning. My handle is Jesterkey.
Okay.
Okay. Sorry. So the conformance test suite integration for us, or at least for me, it is very important to ensure in the long term that we get good support for Blender with COLLADA, because I think it's a very nice tool to use with asset creation to make a part of pipeline. So it was very nice to hear that the how is it called now? The implementers tool? The implementation package, that it is now available for free. And so I registered and started working on doing the implementation for this conformance test suite, or the implementer package with Blender. So, a lot of things. I actually forgot to put down the link for it, but when you have installed all your Python packages, if you can see the first point, so Python, OpenGL, package for Python, NumPy, WX widgets, and so on. You have to create a script. For Blender, I have already done this. It's just this script essentially tells the package, the implementer package, what is your software you're going to test and what can it do. So a very simple script. You have the class with your application name, or essentially any name from application class, and with get pretty name you just tell what your application is. There are some more important parts you need to write down or write out. For Blender we use the background mode, so Blender is being started with a script we generate through this test suite. While it is running, it creates a file that loads the test data and executes the specific step. So there are 4 steps you need to do. You need to import, you need to be able to render and export. Now just quickly create, we already did that. Okay, there we go. So this is the test suite, and I just started a new test procedure. I find, since I copied the script in the right location, which is the scripts directory of your implementers package, it finds our package we need. There's a specific order for actions you need to do. So first you do import, export, render, and then again import, export, and then validate. So we are interested in Blender. We have this, the export, and the render, and then again import, export, and validate. So when you've done that, you get presented with a nice blank slate, and at this moment we are ready to start adding the tests that you want to run for your software. For this talk I'm going to do only a small part, also mainly because Blender doesn't pass any all tests. It does pass some tests. We do everything. Let's do some mesh tests. It should be,
actually, you should be selecting the reference.
oh yeah,
Did you want that as well?
I keep forgetting it.
I wish I could make it out.
Which was so I think, if I remember correctly, I have to say no here. Wait a minute. Right. So now we have here a nice bunch of tests that will be run against your software. And normally I just first test only one test. And it will show you how it works. So the script you have created for your software will generate or set up your software with the necessary scripts that are used for command line usage. And these steps are not being run, so the scripts are being created. And normally it doesn't take this long. Okay.
That's the demo effect.
Yes, I forgot one step, and it's very good to have this demo. Okay? So before you actually start this one, which I should have done before, is you make. Let's just kill it. You have to set the settings for, in our case, for Blender, correct? So let's just do that quickly. So if you config text, and yes, I forgot to add the Blender settings. I have them here. So I should have added Blender path, Blender empty, Blender default name. Just a quick word about the blend. This is a blend file that has absolutely no contents in it. This is done because in the default Blender file there is always a cube, a camera, and a light. And I found that these three objects interfered with doing good tests. So if you have your own software and you are planning on integrating this, you have some data in your default startup, you might want to change that. This default I added as well because I noticed that in some tests, these default cameras or the camera settings that are used for the implementer package are not in that test file. So when I noticed that there's not a camera, correct camera, I can also import this text file, or the COLLADA file, so that we have the proper camera with the proper settings. So let's quickly do that. This one. Okay, I should not have enabled tab completion. Oh, no, I don't have it. And this one, no. See. I should also remember to remove those spaces I just added. So this is now with the correct settings. Let's do this again. I run a lot from the command line, but you should, if you have Python 2.4 only and it has been registered as the default handler for Python scripts, you should be able to just double click the COLLADA test suite Python file. So, run selected. As you see, it now it's much faster for creating the scripts, and then after the scripts have been created, the scripts are executed. So for the different steps that there are, you can check on the output what is happening. Okay. We have passed test. I'm not entirely sure how that is possible. The blast image looks a little bit different from the render. If you happen to have the feeding viewer, then you should be able to also see COLLADA preview in the test suite.
No. Whether, I mean, you could, question, could you put your own viewer there, or any other viewer?
I have only Blender as a viewer.
No, I mean, you said if you have another viewer, you can show it there, so I was wondering if you could use any other viewer to plug it into the test, or if you...
I guess it's possible, yes. The test suite needs to be changed for that, because when I read the code, it has some assumptions hard-coded.
No.
So for this viewer, so if that can be changed, then it definitely should be possible to use other viewers. That would be very helpful.
One thing to understand there, you asked why the blessed image, why you passed when the blessed image doesn't look exactly like the rendered image. That's actually a feature in here. There's some set of tests that check to see whether you passed, and it's more about you being internally consistent. If we're rendering a box, a test might actually check to make sure that if we change the box into twice as large, that one render doesn't equal the other.
Right.
Right? It's not that we're actually taking the blessed images and doing some image compare to say that you're the same.
But there is some image comparison going on with the test.
There is image comparison, but it's always against your renders. So usually image compare is used to make sure you don't do the same rendering as when we vary parameters.
Right. Okay. That cleared it for me as well. I'd be wondering about that. So
I do have some reports. Some people do believe that it's comparing against some blessed images.
yes,
So it's possible there is a
that was also my understanding
Yeah,
with this.
they're not supposed to. So if there is anything that's actually failing you because you don't look like the blessed image, that's not.
Right. Right. Okay. I'd like to ask you after we talk more about how this works.
I have to put my food down at 3:30, so I may.
Okay. So this is essentially how you set up a test suite. If you want to start with just a small amount of features you want to test, that's okay. I tried once to run all the tests, but currently Blender support is not always good, meaning that some COLLADA files can crash Blender, which is of course obviously not what you want. So when I let it run overnight, the next morning I had, I think, 200 Blender crashed in Windows, which was not very nice to click down all those 200.
I have a question. Is there a reference COLLADA implementation that renders?
There is no reference cloud implementation. We pulled the blessed images from an assortment of implementations. Khronos doesn't fund the development of just other reference implementations.
Well, I mean, it's by design. We create the COLLADA so that you can store the information that's required that you need. It is not designed to tell you what you're going to do with it, which was very difficult to make a conformance test for that. So what the conformance test does, it doesn't tell you how it's supposed to render it. It just makes sure that if you render it twice, you render the same thing, or if we ask you to make it twice as big, then make it twice as big. But I mean, imagine your software is a wireframe rendering. There's no reason why it should not be able to be COLLADA compliant, because you are, we are mesh renderer. So the conformance test will make sure you understand what the input was and that your output match the input.
But isn't it very important that I have two products which are COLLADA compliant, that I can actually get the data from one to the other and can expect the same results?
That's exactly what the conformance test does. But what you
said
said
is
is
the data needs to transfer. The cloud is not a rendering standard. So if you have one that's a wireframe render and one that's a radiosity render, and the data is, say, a human figure, it should be recognizably a human figure in both of them, but the lighting model might be very different. So when you talk about interoperability between cloud implementations, you're talking about data flow and assets, not per pixel rendering type pieces.
So if the first tool gets in boxes at the end of the tool, it should be still boxes with the information that was in before, and that information should carry between the different COLLADA tools. Because if one tool completely change the model is something else and lose your origin, the information you wanted to carry over, then that will not be COLLADA compliant. But what you do with the application itself and how you display it, if you, for example, a 3D printer could be a COLLADA compliant tool, and takes 1 hour to make a printed model.
Yeah.
So
I mean, my question is because maybe it's going into too much detail right now, but if we have high quality materials and there is no two renderers out there would reproduce the same results.
Right.
So the question is there something where you try to push the standard forward in order to standardize materials, not just basic materials?
Right, so that's what the graphics library is trying to do by standardizing shading languages and what should be the result of applying a shader material to set of polygons given a set of lighting conditions. That you're going to find that into the rendering APIs. If you do use COLLADA FX, you can store in COLLADA the shader programs that would match with the particular API that you want to use. So, say GLSL shaders or HLSL shaders or CG shaders. You can for a class of device, like for the GLSL class device, you can carry that shader within COLLADA, and the GLSL devices should render the same thing, because that's what the GLSL specification says. Now, as far as COLLADA, we just make sure that if you load a COLLADA FX file into render and then you export it back, then that the FX information is still there.
Okay.
Otherwise, you lost it, and of course it's not going to be available. It doesn't mean that render can display it at all. For example, you can load a COLLADA FX that contains information for OpenGL and DirectX, and you have OpenGL render. So it's not going to use the DirectX information, but it should be able to export it back. Guess what? Most tools can't do that. They don't know where to store information they don't understand. Right? And that's really what COLLADA is about, making sure that you don't lose information, or if you add information, it's consistent. Then once you know you have the data, it's already a good thing. You can make sure that you can transfer it to your customers, like in the case of that, they can make sure they can do what they need with it because it's there.
Okay.
I think that the most important parts for doing the conformance test integration are getting the integration script done that does set up your software for the rendering, the exporting and the importing part. The validating is done with different tools, so you don't have to care about that. And give the essential information that also shows your tool in the test suite. So again, the pretty name that's used to show in the tool, in the test suite. Some get settings for operation, about which I don't know anything yet. As I wrote to figure out how we can or could use this. I think that we don't need any specific settings for testing COLLADA. If it doesn't render correctly, it doesn't render correctly. As said, it's about the data transfer that needs to be inserted. And then writing the script that does either import, export, or start rendering your test that's being run. Some information that was a bit hard to find in the beginning, but I think it's in the tutorial that's been handed out, is that resolution for rendering is expected to be 512 by 512, and I think that was it. For Blender, I think we needed to set straight out mode as well. I think that's the most important parts. And then for the settings, when you change the settings file, and if you have, like we have for Blender, the path to Blender renderer, so you can quickly switch between different versions of your software, and extra settings that you can refer to in your script, testing script. You need to add them to the config text to make sure that there are no spaces. There are only tab separators between the the key and the value. So if you start the test suite and there are errors about complaining about the configure file, then it's most likely about this. Anyway, I think then I haven't been that far yet with Blender either, so I think that the process goes that when you are ready for submitting your software to for batches, then you have to package the results you have created yourself and send them to Khronos, right?
Yeah, there's a submit results on the menu. There's a submit results vendor file, and that'll take all the run you did. It's XML and HTML set of files that it zips up. You submit that on the website.
I have one question at this point myself. How is it determined what kind of batches your software gets, like baseline and so on?
So we've got a set of baseline, superior, and exemplary tests. And so for each test, it's got a set of badging logic for it. So if we're testing a feature like triangle meshes, and for the baseline, you don't need to support things with holes in them. So a file, if it didn't have holes in it, would just check to make sure that it passed. If it had holes and you failed it, you would still pass baseline, but you might not pass superior or exemplary. So it's basically keeping, as you go through it, if you fail any exemplary test, then you can't have exemplary. If you fail superior, you can't have a superior test. If you fail a baseline, then you can't have a baseline package.
Okay, thanks. Does anybody else have questions about this?
And do you know where you're at with COLLADA for Blender, and how many of I mean, knowing what doesn't work is one thing, but then how many of those things you have to go back and fix, and how difficult it was, and how is there any things that you say I would never be able to fix that because Blender just doesn't do it that way?
There are some things that are completely different from what the COLLADA specification expects. One of the things that was a little bit problematic were materials. Blender does materials in a little bit different way than specified. For Blender, it's, I think, perfectly possible to have, I don't recall correctly which of the shaders were speckless, but to have a shader that by the COLLADA spec is diffuse only, but still have spec in it. So for these, actually, the test was helpful in that sense that it allowed us, or me, to run tests, and in most cases just catch all the crashes that we had, attach a debugger, and then fix it. It was really helpful because most of the test files we get were from the old COLLADA all repository, and I understand that these test files are a little bit old already. So it was really nice to have a small test that test specific features, and when there is an error with the output, so you get a nice red warning sign, there was some test failed. It's easier to find, just to minimize the amount of data that is around the feature tested. Often we get a COLLADA file that is huge and says this does not import correctly. And it is not really fun to go and read through a COLLADA file that is several megabytes large. So having these small tests is a really big help in just localizing the features and the problems with the features that are in Blender. And that has helped a tremendous lot.
We're also hoping that people will use them during their testing procedures. When you've got a new candidate release,
Yes.
if you can put it under this, gives you kind of a quick check of several hundreds or thousands of files that can exercise the software.
Yes, I agree very much. Currently with Blender we have a very light testing procedure, meaning mostly that we do a release candidate and then tell users, use this, tell us if there are any glaring problems with it, like crashes on startup. But a real test suite has lacked, and especially for COLLADA support, this has been really nice to have access to.
Question that comes to my mind is sort of robustness of error feedback in repository of solutions, or what exactly do you do when you get an error? I guess comes to mind.
You mean specifically with Blender?
Well, you sometimes it says there's an error, or you didn't see that demonstrated. Like, how good of a feedback is that for one to address?
For the test suite, I have found that the best way to get feedback error is to run, as you can see here, to run the tests from the command line, because everything is printed out on the command line, and I have written my test script in such a way that for every step I print out what I'm doing with what files and what location. So it's easier to find which location, and as you just saw, this is a new one. I haven't seen this one before. Looks like an error with the judging code of the implementer package. But at least it gives, through the command line, it gives you the information what otherwise would just be somewhere. Because if you just double click the test suite, you have the nice graphical window, but no information about what is the actual error. Like, is there a problem with your script you are developing, or is it just an error because your software doesn't yet support the COLLADA beat correctly? So start your program in the command line, and you see everything you don't want to see.
What kind of information you have? If you want to know what is that test doing? What is it testing? Does it, can you find that on the UI? Can you say, what is that thing doing? What is it testing exactly?
Let me find what
What's
is.
the goal of that?
And there is some information in the description, I think. Like here it says, the category tells you something about what kind of test field, and there's often some kind of description. Test triangles, or test handling, semantic normal in triangles primitive. That is the the direct information you get through the CTS about the tests. So if some of these fail, let's see what field.
There's some more information.
Yeah, there's for the steps, actually. Yes, step one. This is the output from the script you have to create. And this is actually Blender output you get. But if there are errors, for instance, sometimes Blender did crash silently for some reason, I'd be able to find it because all this nice rendering information is missing. So to check these logs as well, you can annotate your tests by adding comments if necessary. These steps that you have here are generally about the output of your script and your software during the test run. And the command line I talked about is about the test suite itself, when something happens with it.
So catch me online if y'all got more CTS questions. I'm Alan Hudson.
Okay.
I've got to actually go help take out a booth, so sorry I can't stick around too much longer.
So I think this was enough for me. If people have more questions about the test suite, I guess just comment after the talk.
So we can switch to the next and last speaker. It seems, unless somebody showed up from Oregon State University, you are here.
I am.
All right, so come here we